Time, even though there's still hundreds of people streaming through the halls. I'm Brad Myers. I'm the chair of the ACM SIGCHI Awards Committee, and it's my great privilege to be able to introduce Terry Winograd as the winner of the SIGCHI Lifetime Research Award. So you may know that SIGCHI gives out many awards, but the SIGCHI Lifetime Research Award and the Lifetime Practice Awards are our biggest honors, and we honor these people with a plaque, a check, and also the opportunity to give you a speech and hopefully enlighten us about what they've learned through their lifetime of research or practice. So our Lifetime Research Award winner this year is Terry Winograd. Terry is a professor of computer science at Stanford University, where he founded and directs the program in human-computer interaction. And it doesn't mention in this blurb, but he also, of course, founded the design school there. Over the course of his 40-year career, Terry has made fundamental contributions to the design of interactive computer systems by taking a broad view of HCI, considering it in the context of natural language processing, machine and human intelligence, cognitive science, human-machine communication design, and software design. Anybody who's been in the field as long as we have knows that you generally come from other areas, and Terry has come from AI, which is certainly one of the key reasons that he's been able to make so many interesting contributions that are very different than the contributions of those who come from systems or from psychology. So it's great that he's able to give us this different perspective. After building one of the most advanced natural language interactive systems of its time from his early work in AI, he showed that the symbol-based system was inadequate and proposed a new basis for human-machine interaction that emphasized the contextualized basis of communication in the physical world. Thereafter, he developed the consequences of these ideas for software design and showed how human activities, computer science, and design can be united not just through a series of articles and books, but also through the design and teaching of a set of classes and the founding of a new design school. Terry has explored other dimensions of the relationship between people and computers, receiving the Rigo Award for Lifetime Contributions to Computer Documentation from the ACM SIGDoc Society, and the Founders Award as one of the founders of the Computer Professionals for Social Responsibility. He has been a major influence in HCI through broadening its perspectives, demonstrating the relevance and importance of diverse schools of thought to understanding and designing interaction. Terry.
Thank you, Brad, for the honor of this award, for you and the committee. I'm privileged to be here in the company of many of the previous winners and, of course, distinguished members of CHI and fellow researchers. Given that this award means that I've been around a long time, I was going to take the opportunity to sort of reflect on how CHI has evolved over that time and bring up some oldies but goodies from the past. I have to admit that when I was putting it together, I went through a lot of old pictures and stuff, and I was amazed at how many of the things we sort of see as new and current today really had their roots back decades and decades ago. So that's been fun. Of course, there have been tremendous changes. These have been driven and punctuated by major shifts in the technologies we use. But there is another dimension of change, which is not so much the artifacts that we build or we use, but the way that we understand them, the way we design, the way we think about what we're doing for the people who use them. So what I want to do is sort of go through a series of shifts in perspectives and intersperse some stories and lessons that I've learned along the way. I've moved, as Brad mentioned, steadily over the years towards a notion of design. And by design here, I don't mean what the popular view of design as styling and look and so on, but really design as a mode of thinking, as a way of approaching problem, a way of approaching interactions and approaching working with people. So I'm going to lay that out in a sort of historical direction, look at the idea of computer-human interaction, CHI, starting with something about computers and interaction, but not focusing on that. So that's going to be a sort of prelude. And then once we go further, we'll take a look at what we really mean by the human part of human-computer interaction. So the first question is what's happened over time and how we think of interacting or what a computer is. I found this wonderful picture of a crank-driven computer. This is not actually Charles Babbage with his analytic engine. It happens to be Doran Swade from the London Science Museum who built a model of Babbage. But we all know that computing, as we think of it now, has long roots, and interaction in those days was a very physical, direct thing. This is long before we had tangible computing. This is pretty tangible. Moving to what we now think of as real computers or digital computers, in the 50s, there was UNIVAC. This picture happens to be Grace Murray Hopper, who's often considered the first programmer or the first designer of computing software. And this is the UNIVAC. As you see, a bunch of people sitting around a console and interacting directly with the machine. My own first computer was the one that I built for my high school science fair. This was, with parts from my father's junkyard. It had a lot of sort of electronic scrap. So I put it together, entered it in the science fair. And what's interesting is that what happened sort of prefigured a lot of discussion that went on later in computer science, which is I was highly disappointed not to win the science fair. And the judges said, this is a really interesting and clever and valuable thing, but it's not really science. It's engineering. So that theme got started many years and has persisted. A few years later, what we mostly thought of as computers was something more like this. The mainframe, big room, glass walls, lots of spinning tape drives, and people in white shirts and ties sort of managing it. Right? Now, what's interesting, and of course the way we interacted, to pick up the theme of interaction, was things like punch cards and paper tape. You put the bits into the paper and they got read into the machine. What's interesting is at about the same time, this is in the mid-60s, my first digital computer was this one. Anybody recognize this computer? Okay, no real old-timers here. It's control data. Okay, you think of control data as building things like that previous picture with all the things and stuff. This was the control data 160, which is one of their early models, and that is the whole computer. It was a desk, and you could sit under it and use it like a regular desk. Inside there was a small amount of memory, 12-bit memory, 12 bits of address space. You can multiply it out a few kilobytes. And the input and output was all by paper tape. You see the paper tape punch. That's the paper tape reader there at the top. Paper tape punch was on the side. Due to a complex accident, I was at a small town in Colorado where I went to college, Colorado College, and a doctor came to the local medical center having gotten this on a grant when he was in a larger medical center. And he got there and nobody in town knew how to run a computer. And he called the college and said, do you have any math students who might be able to figure out computing? So I ended up with this as my personal computer for 2 years. I didn't know anything about compilers or assemblers, so I actually encoded everything into octal numbers and punched them into those buttons on the console. At first, I did learn later. But it was really, I think for me, it started my whole sense of computer-human interaction with the idea that you are there, the computer's there, and you're interacting back and forth. It was none of this, take your deck to the computer center and wait to see what comes back. I did learn also another lesson about bits and atoms, as they say, which is on a hot day, there was not a lot of cooling in these, so we had a fan sitting behind the computer. And I managed to read in a program tape right through the reader into the fan. So it's sort of exciting to see, as we say, the bits hit the fan. A little bit later, computer interaction shifted from punch cards to time sharing. And again, for those of you who know the history, this happens to be Joe Weizenbaum. I'll talk more about his work later. But the idea of time sharing, developed by John McCarthy and others, was that you typed into a teletype and it typed back at you. There was an immediacy. It wasn't mediated by time. Shortly thereafter, there came a very big change. And I actually went to Xerox PARC in the summer of 1972 when it was just starting to get together. And of course there was a huge surge of really amazing technologies that came out of the group there. Alan Kay, of course, drove the development of the Alto in many ways, the software. Larry Tesler, who will be receiving the award tomorrow for practice, was one of the people, along with many people there who have gone on to win Turing Awards. It was a really striking assembly of talent. And they developed a kind of machine, the GUI as we call it, a set of techniques, which this falls under the category of striking how much of what today looks like what they had 30 years ago. Right? It's a huge amount of what we take for just ordinary everyday computing grew out of that group. And I tend to be, I think, in this history a little PARC-centric, but that may be because that's the way the field is, as well as my having been around. Slightly before that and leading into PARC, there was another strand, and I'm going to talk about this a little more when we talk about groupware and things like that, but Doug Engelbart had a very different vision of what computing was about. It wasn't about getting answers from a computer, it was about communicating with people. It was about a network of interactions, person-to-person interactions. This is a picture of him at what is often called the mother of all demos in San Francisco in 1967. 68, sorry. It really shifted, I think for a lot of people, it shifted the view of what computers are. Computers aren't things you interact with, they're mediators in a network of interactions. A little bit later on at Xerox PARC, Mark Weiser and the idea of ubiquitous computing. You see there the iPod, the iPad, and the, oh no, it's the PARC tab, the PARC pad. The idea of having what he called computing by the inch, the foot, and the yard, so that a computer could be a very different size and form factor depending on what you were doing with it. And the live board is the one below. This was a experiment that we did at Stanford a little bit later on. I wanted to just bring it in here since it followed directly from Weiser's work, which was integrating multiple devices into what we call the interactive workspace. Did this with Pat Hanrahan and Armando Fox at Stanford, and we had tabletop, we had walls, we had handhelds, we had laptops. You see the whole range of things. And the goal was to come up with a way to integrate those into a single sort of interactive space for the user. So it wasn't one kind of interaction, another kind, another kind. Some interesting systems technologies developed. There was a startup called Tidebreak done by a couple of the students, which is still going, selling software in academic settings. There was a very interesting specific interaction design done by Francois Gometier, who's here, using a pen and a large high-resolution display for creative work. So he called it post-brainstorm. It was for the kind of activities you do, not when you're sitting down and getting stuff done in your office, but you're in a group trying to come up with creative ideas. So there were some interesting things that came out of it, but I'm going to say we were not really successful at our larger goal of integration. And I think this was one of the lessons that I learned. At the end, I'll talk about lessons in general, but in failing to turn a bunch of devices into a kind of unified environment, what I realized is having a good conceptual framework isn't enough. You know, that when you're dealing with a kind of heterogeneity of interaction and devices and people, there's a huge variety of both social and technical and physical detail that all needs to be taken into account. And it's really, integration always sounds good, and it would be wonderful if you could do it, and is much harder in practice. So I'm not going to try to give a full history. I mean, this is a very selective history of what computers have been, but I'm going to switch to, excuse me. The human part of the equation. So the question is, what is a human? That's a good question. Of course, one that's had a long tradition. Here is an answer from about 500 years ago or more. Leonardo's image of a man, we now take generically as human. Here's one from about 500 years after that, which is interestingly similar. This is actually from Henry Dreyfuss's book called Designing for People, he had models he called Joe and Josephine, and you see people as having a whole set of measurable human properties that affect what they can do. I can reach a certain distance, I can poke a certain button, I can do things because of the length of my arm, the length of my leg, whatever it is. This was a view of people as physical beings, which is called, at the time and still, human factors. I was struck, I actually hadn't noticed this, but I was walking over here this morning, I noticed that all of the electronic billboards for all of the sessions and everything say, what do they say? CHI Conference on Human Factors in Computing Systems. So that phrase, human factors, has actually stuck as a kind of way of thinking about our field. But of course, human factors has expanded. As you can see from the format of this slide, we're going to be building up a list that's longer of the different ways in which we look at what a human is. One early one that was very influential, originally put forward in a very explicit way by Alan Turing in his paper in 1950, was that what it means to be human is to use language. If you could understand and dialogue in ordinary language, that would be the test of intelligence, okay, a test of human intelligence. This has been reflected in the pop culture. This is an interesting icon. Does everybody know who this person is? It's Hal, right? Hal, who in Arthur Clarke and Stanley Kubrick's interpretation is a very human-like. Okay, it's human in many, many ways, and that are played out in the movie. So the philosophy here is that a human is a physical body. Yes, we all have that. But what's more essentially human is a language understander. Earlier I showed you a picture of Joe Weizenbaum. His program from the early 60s called ELIZA was tremendously influential, caused people to think really in a different way about what computers could do. It carried on dialogues like this. You were like my fathers in some ways. What resemblance do you see? You were not very aggressive. My father is afraid of everybody. What else comes to mind when you think of your father? Bullies. So this is the kind of dialogue a person might have with a therapist. And what's going on the computer side, wherever it says ELIZA, is a very simple pattern matching program. It looks for certain phrases, certain combinations of words, and feeds them back. I mean, I gave ELIZA as a simple exercise in programming classes for many years. It's very unsophisticated as a program. On the other hand, people saw it as an amazing demonstration that computers could use language like humans. So this is my next lesson that I want to sort of point out in various places, that people simply cannot refrain from projecting human qualities onto computers. When it looks like it's doing a little bit of human stuff, you immediately project much more humanness. This has been studied in detail. Sherry Turkle has written books about how people perceive computers. My colleagues Byron Reeves and Cliff Nass at Stanford have done a long series of research, all of which lead to this same, or demonstrate in various aspects this same issue, that people think about what computers do because they're thinking about what other people do. Now, I got into this language game with a program that's probably what I'm best known for still, called Shrdlu, and this is from the original screen. You typed in things like pick up a big red block, and it would type things back, sometimes much more elaborate than okay. It could say how many blocks and so on and so on, and actually would carry out the operation on this primitive graphics screen. Again, this caused a tremendous amount of interest because it seemed to be something you wouldn't expect computers to do. Remembering that at that time, computers were thought of as the big mainframes and all those kinds of things. It got a lot of note. The dissertation was made into a volume of cognitive science and then into a book. This is actually the cover from the first edition, which was put out by Edinburgh University Press, later by American publishers. I find it an interesting format to have the author, the title, and the press all sort of put together in the cover. I wanted to just quote something from what it says. A computer cannot deal reasonably with language unless it understands the subject matter. And notice that's sort of pushing it. It's called understanding natural language. This notion of understanding was part of a larger effort in artificial intelligence, as Brad mentioned, from the AI lab at MIT. I had the hair then, it was just a different color. That upper left, you see the PDP-10, which was the computer we used, and that round screen is actually what all those blocks were dancing around on. The person who was really the head of the lab was Marvin Minsky, who you see there with some robot arms. And the idea was that you would be able, with a certain set of symbolic algorithmic techniques, to duplicate all of human intelligence. Language, motion with robot arms, things like that. That it was just a matter of getting the right representations, the right programs. Now, I had success in the blocks world, as it was called, and in a way at that time didn't have the same view I do now of why that was. We thought of it as sort of like experimenting on fruit flies, right? That is, you don't start off doing complicated genetic things with big, hard to reproduce animals. You start off with fruit flies, and then you learn the principles, and then once you've learned them, then you go to the bigger, more complicated things. And I think the blocks world was a kind of fruit fly of AI. But looking back over the years, I think that the success of the program was because it was able to tackle such a limited domain. I worked for a number of years at Xerox PARC in the natural language group. I always like to say PARC developed all these wonderful things, you know, networks and printers and personal computers. I was there, but I was in the group that didn't. I was working with Danny Bobrow and Ron Kaplan, Martin Kay, Don Norman was there in the natural language group. And again, looking back, I'd have to be fair and say that did not lead to the kind of success we wanted. Over the years, that group did some interesting things, eventually produced a company called PowerSet that got sold to Microsoft, and then sort of disappeared. I mean, it's certainly not out there. It didn't tackle the limited domain problem. It said, let's tackle anything people want to ask, and I think there are good reasons, which I'll talk about in a minute, why that really is a different kind of operation. Now, there's, of course, one more recent attempt to do this. Who knows the question for this? I'll read. It can rapidly answer a wide variety of factual trivia questions without having the faintest understanding of their meaning. Who is Watson?
What?
Or what is Watson? That's a good point, right? So what's interesting about Watson, which I'm sure most of you ran into, there's a lot of press about it, IBM's recent program for answering trivia questions, or Jeopardy questions to be specific, is that it really doesn't attempt to do what we, in all of those years of AI, talked about as deep understanding. What it did is have a huge database of things which enables it for almost anything you ask to go find the relevant things, and a lot of clever programming, and it's a very complex and clever program. But in the end, it's the Eliza lesson. When you see that playing Jeopardy and winning, you think, oh, I could have a conversation with it, he'd be really smart. The answer is you couldn't have a conversation with it at all unless you ask it Jeopardy questions, right? So I think that lesson is still learned over and over again because we're always surprised by the things that computers can do and make assumptions about what that means they could do beyond that. So going down my list of what a human is and what we need to, on the right-hand column there, I'm going to put fields. And linguistics is a sort of a shorthand here for all of the fields that study language. And in a way, this is sort of how Kai has added more and more space. We are adding, as we go, fields that are relevant to understanding that part of what the human is. From about the same time as the work I was doing in AI, there was a model of what the human is. What's striking from this left-hand picture is how similar it is to Dreyfus's Joe and Josephine. Right? It's just that all of the little legends and numbers are in the head instead of in the arms and the legs and so on. But it's the human as a measurable set of cognitive properties in the sense, the long-term memory, the image store, and so on. This is the famous bubble head image from Card, Moran, and Newell. On the right, this is actually from Newell and Simon's 1972 book on human problem solving. I don't expect you to read it, but the idea is that what the human does is like following a flowchart. It's like doing a set of algorithmic steps on a bunch of data which represents the problem. So the model here was that the human is an information processor. Okay, that the things we think about when we talk about computers processing information can be projected into what the human is like, that they do things like decision making and problem solving, which are well-defined operations. And of course, Newell and Simon had a whole career of developing the principles of what it means to be an information processor. My own textbook on language, which came out a few years after the dissertation, was called Language as a Cognitive Process. Okay, so even though there were internal differences, I would say, between the Carnegie School and the MIT and the Stanford and so on, there was an underlying sense of similarity that what we're talking about when we talk about people from a mental perspective was something like an information processing device with a set of pieces, a set of properties, and so on. So that brought in cognitive psychology, and in some sense you could say that the real main line of Chi for the decades since then has been driven by that connection. It's been changing over the years, we'll get to that, but I think that Chi as a study of the human properties of the human information processor as it relates to interaction has driven a lot of the theory as well as a lot of the specifics. This was a very different approach. So here you have Doug Engelbart, again, if you look there in the right, with a team at SRI. This is before the Silicon Valley dress code had evolved. And his view was that the way you wanted to look at people wasn't what was going on in their head, but how they interacted with a team. How do you augment their capacity in a work team? This was a very alternative view. It later became the whole field of computer-supported cooperative work, which has spun off and done a lot of interesting things. It was a move from looking at the individual to looking at the interaction between people, not between people and computers. Now, I actually heard Engelbart give a talk at MIT back in the late 60s. And as I mentioned, I was part of the artificial intelligence lab, and the consensus there was, that's a really stupid thing to do with computers. They aren't smart. Okay, that is this whole vision of menus and all the stuff you could do with that. Where was the intelligence? Okay, so notice the shift here is you don't make the computer be the thing that's smart, you make it be the communication tool, the way that people be smart with it. So a worker in an organization is another kind of thing. An organization here you could take broadly, it doesn't have to mean a commercial business, is a view of what people are and what they do. And you can project onto that the kind of cognitive view. This is from Nutt and Ellis back in the 1979 view of what goes on in an office process. And it's very much like the algorithm. It's almost exactly like the one I showed from Newell and Simon in '72 if you don't read the exact labels. But I got involved with a somewhat different view through my connections with a fellow named Fernando Flores. And at first glance, it sort of seems the same. It's a bunch of arrows and circles and so on. But there's a shift of emphasis here about what you're doing. From saying what you're doing is getting a series of operations or tasks done, which is the sort of conventional workflow view, to what you're doing is in the space of how you make commitments to other people and how you manage those commitments and understand what you will do and what they will do. And it's one of these shifts, and this is another one of my lessons I'll talk about later, where it's hard to realize why it's different. It's sort of the same thing, but it's like looking at the mesh in the net instead of looking at the strings. I mean, it's a very different approach. It leads you down very different lines of what's important and what to do. It's an ontological difference. Okay, and ontological is one of those sort of words that gets thrown around a lot. And I never used it until I got into this particular connection and got drawn into looking at philosophy, at phenomenology. Ended up writing a book with Flores called Understanding Computers and Cognition. Notice Understanding and Cognition still show up there. This grew out of, in part, a series of discussions that we had. This is after I had moved to California with Bert Dreyfus and John Searle, who were at Berkeley. We used to go up and meet with them. And there was a whole ongoing sort of ferment, I guess is the way I would describe it, rather than a well-focused debate about what was cognition, what were computers, how do we understand interactions with them. And this led to my really shifting gears. Okay, so again, as Brad mentioned, I was sort of in the AI mold and really had a different underlying understanding of what the computer was doing, what people were doing when they used it, led me into considering what I was doing be HCI, not AI, and led to a whole different set of approaches to how do you make this work and how does it relate to design. And I'll talk about some of those later. So, a worker in an organization is also a source of commitment. And the fields that get brought in here are, and again, this is a shorthand, I put up management and business, but the point is that the fields which deal with how people operate and make things happen in organizational structures is a part of HCI. It's a part of how we need to think of people in order to do the design, do the research that we're doing. Now, shifting back, there's another view of people, and I found this wonderful slide. This is an ebook. Does anybody know what vintage ebook this is? Michelangelo, Agnes. It's not a Kindle. Okay, this was done on the Xerox research character generator in 1972. Alan Kay and then people like Chuck Thacker and Butler Lamson and so on had the idea that you'd want to read a book on the screen and that you could have fonts and all that kind of stuff. So the idea here is that people want to use computers for information, for direct access to information. I was part of a project at Stanford in the mid to late 90s called the Digital Libraries Project. We had a lot of different pieces to that project. You'll notice here some things that are very reasonable and some that are old, like what was Z39.50? That was a protocol for passing around sort of bibliographic information, which preceded the web. There was HTTP on there, but it was just before the web. And the way we thought about information was the way librarians tend to think about it. Well-organized collections, things that brought together carefully curated materials. You had things like commercial information brokers and providers, things like Lexis and Nexus and so on. And the goal, again, which was an integrative goal, was to pull all of those together so that a person sitting in front of a computer could access the interfaces, the payments, the libraries, and so on in a uniform way. Now, again, lessons learned. I think we were trying to do a complex integration task, which was interesting and probably more doable than the iRoom one, but it all got blown away when a couple of our students decided that they wanted to search the web. So Larry Page and Sergey Brin came up with Google. This is a 1998 version before they had figured out how to draw a nice logo. And they came up with the audacious idea that you didn't need to organize anything. You could just take whatever was out there on the web in whatever form it is and search it, find things in it. And I have to admit, when that came up, I was a bit skeptical. And it wasn't like I said, oh, I see the light, right? It was like, wait a minute, how are you going to, no. Now, Larry often credits me, which I appreciate much, although I don't know if it's true, with having given him the best advice I ever gave him. I'll come back to that later. But the point of it is that we were able to make the switch by what they did from a view of information as an organized sort of pre-canned structure to this view of searching in a massive and unstructured way and using the sheer amount of that as the basis for being able to come up with things and pull them together. And the PageRank algorithm is a whole series of developments. But for me, it was a real sort of mental shift from careful ontologies and structuring to open-ended use of wide ranges of materials. So you could argue that from this point of view, a human, and this is of course a prominent view, the web, is an information seeker. What do people do on the web? They get information. Right? They may get it through Google, they may get it through Yahoo, they may get it in all sorts of ways, but they seek information. I put the word informavore here in honor of the information foraging work that was done by Peter Paroli and Stu Card and other people at Xerox, where they really took the metaphor that somebody who's out looking for information is like an animal foraging for food. You need information to survive, and you go out and you get more and more and more of it, and you need to be able to find it efficiently, and so on and so on. This view has driven a lot of what's going on in HCI for the last, this is much more recent than the psychology side, again, I've sort of put in some shorthand, information science and information design. But that includes librarians, editors, I mean, all the different people who think of what they do as work with information as opposed to think of it as work with computers. Now, I think this is, of course, a very valuable view, but it misses a key component that came along a couple years later. This is, again, a very early example. Probably looks like a bunch of people having dinner. No way you'd know what it was unless you happen to notice this is a photo by John Coate. Anybody know who John Coate is? He was the original, as he called himself, the innkeeper on The Well. The Well was the first, or one of the very first online communities, and the idea that people got together socially using computers. Now what's interesting here is this is their chili cook-off, right? They actually got together physically as well as socially. But the life of The Well, Howard Rheingold, who gave the keynote, right, was a key person in those early days in The Well, that it was a matter of people getting together. That's very different from the Google mission, which is, quote, you know, make all the world's information accessible and so on. That doesn't say anything about people getting together. It says the world's information. So it's a shift from the information to the people. People are social. Now, one view of people being social is the current large amount of work on social networks. Okay, so you see here somebody's diagram. They all look more like it. There are actually little pictures of people there, and I had a figure which didn't get onto the slide. I'm probably looking very long, but anyway, I don't have the exact number, but there was Wikipedia, there it is, gives a list of major active social networking sites, not excluding dating sites. And there are over 200 notable, well-known sites. So you start with Facebook and LinkedIn and so on, but there are 200 notable, well-known ones and tens of thousands, hundreds of thousands. This has become a sort of burgeoning industry of how do you see people as social beings. Okay, their essence is they socialize with each other. This brings in sociology, anthropology, a whole body of human sciences or human studies about people and how they get along with each other and what they do with each other. Now, along with that, and I'm going to use this as a kind of transition to talk about, springboard to talk about something that I think is deeper. This is a social site. This is Ashton Kutcher's Twitter page. And what's interesting about Twitter is that when it first came up, how many of you had the impression, my God, I would never want to put stuff online like what I had for lunch. What the hell is that thing for? Right? That is, if you think of information, the question, how much love you got, who wants to buy some gum, I mean, that's not information in anything like the sort of sanctified sense we think of it. So why do people do it? Why do people spend so much time on Facebook? Why do they spend so much time on Twitter doing things which are from that previous point of view, very low quality, low interest information? I want to argue this has to do with meaning. That's what I want to talk about for the next section. And I don't here imply meaning in the sense that I used to when I did natural language. In natural language, you have syntax, semantics, meaning, and so on. That's a sort of specific linguistic view of meaning. But I mean it in a deeper sense, and I'm going to use an example from a different domain. This is from my colleague Michael Barry at the D School at Stanford, who is an industrial designer. And one of the projects he had was to redesign diapers for Kimberly-Clark. And as he describes it, the rest of the people on the team, the engineers, saw diapers as complex waste disposal bandages. And the idea was to make it fit better, leak less, be quicker to put on, all those things, right? I mean, that was the point of a diaper. He went out and he studied people. He didn't study diapers. He didn't even study kids. He studied parents. He talked to them. He asked what they cared about, what they wanted in their diapers and so on. Not what they wanted in their diapers, what they wanted diapers to be like. He came up with a concept which has since revolutionized the industry, of Huggies pull-ups. Now, what is the advantage of a pull-up? Well, the first thing you notice if you have young kids is they're harder to use because you have to get the pants all the way off before you can get a pull-up on. Whereas you can get a regular diaper on with just pulling the pants down a little ways. So actually, and they probably leak a little more, I don't know about that, but from a pure mechanical point of view, they actually aren't as good as a more conventional diaper. But they changed the meaning. The meaning is, I'm a big kid. This is my first pair of underwear. I don't need regular diapers anymore. And marketers are not subtle. You'll notice in this marketing picture, they stick a necktie on the kid, right? Okay, we get it. He's grown up, right? So the point here is that the meaning of a diaper is something more than the function of a diaper. When it means my kid's growing up, he's getting bigger, right? And again, it's the parents, not the kids. The kids do it too. I mean, the kids are proud of it as well. So I think in design, and in HCI as well, meaning is one of the things that drives it. The meaning of Twitter, partly, is being a celebrity. I have lots of followers. Notice the difference between on Facebook, I have friends. So now I'm part of a community and we all like each other. Implicit, not explicitly. And on Twitter, I have followers. I'm famous. Right? So I'm famous is a meaning for people. Okay, it's a different question from I produce information. Right? Just not the same. So we can see that this view of people says they are the source of meaning. And the question isn't so much what do people do, which is what we've been talking about, but who are they? Who am I? How does that affect the notion, the fundamental notion of I'm a big kid, right? Who am I? This is probably the most famous internet cartoon ever. You've all seen it. On the internet, nobody knows you're a dog. We all have a personal identity that we maintain. There's some notion of who am I is the I that my friends recognize that's different from the you, and so on and so on. And I think there's been a lot of work in HCI about personal identity, things like customization, personalization, tremendous amount of interesting things that can be done there. But personal identity is only one part. There's a larger sense of social identity. Not just I'm a person who likes this and does this and so on. Here's my hobbies. I mean, all the stuff that goes on the front page of your Facebook profile. But I have a reputation. I have some kind of social validation. And I think a lot of what we're seeing again in computer interaction is playing to this kind of a meaning. This is my daughter's blog. She happens to love baking, and she's observant Jewish, and so this is how can you make things that are milk-free so you can serve them with meat, and so on and so on and so on. The point is that there are, and again I'll quote from this, 150 million websites currently identified as blogs. That's probably not 150 million people because some people have more than one, but a blog is something which says, I have a reputation, people read me, I have people who are interested. You can get the analytics page, it shows you exactly how many people have looked at your blog on any given day, you have comments, they can respond back to you. So a blog is a kind of social presence. I put here that as a catchword, fame and fortune. Now, for this blog, I guarantee there's no fortune involved. There are some that do have substantial things. But it's sort of what in prior days you did by going out and starting a business or being in a field. Now you can do online with a blog. But again, fame and fortune are ephemeral. There is a deeper kind of social identity. Who am I as a person in the world, which has to do with family and friends. And that's, of course, what Facebook plays on. I had a slide I took out because it was unreadable, but it was my Facebook page, and the word friend appeared on it 17 times. Right? Your friends do this, and do you want to friend this, and friend this, friend this, friend that, friend that. Right? So it's creating this meaning of being part of a community of friends. Same thing with family. And I think it's interesting how much, as always, with technologies, the technology of computing has been adapted to strengthening family in some ways. This is a picture not of me, but I've done exactly what you see there, which is read a book to a grandchild over Skype. So something which we could take as a commercial, teleconferencing or whatever, takes on a different meaning when it becomes part of enforcing family. I had a friend, BJ Fogg, some of you know, started a startup at one point, which was specifically to have audio messages shared in the circle of family. There's genealogy applications, there's a whole set of things which draw on that desire. Broadening out, we're part not just of a family and friends, but a larger community or society. And I think that impinges on how we think of computing. My own history, which Brad mentioned, I was involved in the founding of an organization called Computer Professionals for Social Responsibility. This was originally in the 80s as a response to some very unrealistic assumptions that were being made in the defense world about how computers would provide a missile shield. And we had a number of activities and publications about the realities of computers and accuracy and reliability and so on, which meant that you would be depending on a missile shield that was almost 100% certain not to work. Later got involved with issues of privacy, a number of issues about how computers impinge. I personally was involved for a number of years in discussions about military funding for research. And Kai has been, I think, less part of this than the mainstream computer science, which for a period of years was almost entirely funded by DARPA, the Advanced Research Projects Agency you see up there. And there are some complex, and I have to admit they're complex questions about why you should or shouldn't do that. The thing that really pushed me in that sense was there was something called the Strategic Computing Initiative, which was different from Star Wars, which was using AI techniques, let me not get into details, and it became clear that they were giving out money to respected researchers and then going to Congress and saying, see, you need to support this program because these famous people believe in it. So even if the thing you were building was in some sense not problematic, the whole process, the whole culture was. Many other ways in which computers fit society. Ben Schneiderman, who's here, has been active in that area for many, many years, pulling together computer-human interaction with questions of politics and society and how can we play a role in social issues. I recently, the last couple of years, have gotten involved in something called the Liberation Technology Project at Stanford. This is just a thing of our website. I didn't have a good graphic, of our blog, another one of those 150 million blogs. But the idea is a range of activities in applying communication technologies to democracy and development. It includes conferences, the blog, Twitter as well, I have to admit, research scholars, and a course that I'll talk about in a couple minutes when I talk a little more about design. This is the last strand of what I want to bring out. What is design? And I've been thinking about this for a number of years. Earlier I mentioned Henry Dreyfuss, and this is his book, and it's unfair to sort of pin him with the pictures of Joe and Josephine because that was only one small component. He actually, back in the 30s and 40s, created what we now think is the field, modern field of industrial design. He actually came from theatrical design, and that led him, again, as Brad points out, where you come from makes a big difference, to think about design as experience, not as engineering, not as building a thing, but as creating an experience for people. And that has been the sort of driving force in bringing design to human-computer interaction. That it's human-centered in the sense of centering it on the experience. In the 90s, I was influenced by a number of people, including Don Norman and Mitch Kapor. We brought together a group of designers from different fields, as well as computer people, to look at the questions of how design plays out in interactions and how it plays out in computing. At that same time, more or less, we started the human-computer interaction group at Stanford that Brad mentioned. It's been about 20 years. We just had a nice celebration. And that had design as a key element from the beginning. 20 years ago, when we set up a seminar series in which I can look around here and say a number of you have spoken in it, it was called the series on people, computers, and design. That was the name of the series. We've now had over 500 speakers. And one of the students just put up a great web page with pictures of all of them. I'll send you a pointer if you want. So we started teaching design-oriented classes. And this took a turn when I started teaching a course with David Kelly, who is at the firm IDEO, also the Stanford design program. And in that course, it was founded by it was sponsored by Apple and Joy Mountford, who at the time was at Apple. And it was focused on using interdisciplinary interaction as a way to bring out new possibilities in design. He was in mechanical engineering, I was in computer science. And then by a striking turn of fate, a few years later, he was able to influence a fellow named Hasso Plattner, who was one of the founders of SAP, who was convinced that design was really the way to think about not just computers, and not just HCI, but all sorts of engineering and all sorts of innovation in all areas. And he created this thing we call the D School. Now, it's not a school. It's an interdisciplinary teaching program. It has no faculty, students, or courses of its own. Everything is interdisciplinary. It's between departments, which is good and bad, but it does keep it from ossifying into a particular style. And here is where you'll see that sort of list that I've been making on the right. There is deep thinking that has been done by all of these different fields that is relevant to how people interact with computers. And the goal of the D School is what we call human-centered design, design thinking, which is ways of bringing that together in a unified way, an integrated way, so that you're thinking both about the person as an object, the person as a cognitive being, the person as a social being, and so on, when it's relevant to the thing you're designing. One of the things I've been doing there, and this is now just the second year, so I can't say it's an experiment, still in progress, is a course I teach with Josh Cohen, who's in political science, in which we have students design mobile applications for health and development in Africa, in Kenya in particular. It's a collaboration with students and faculty from the University of Nairobi. This is actually a picture taken on their campus. Josh is the fellow on the opposite end. And also with NGOs, non-governmental organization, one called MISA, the Youth Sports Soccer Association, one Monday Trust, number of them, so that it's a joint project between the organizations that are actually working there on the ground, our students, and students and faculty from the University of Nairobi. They do small project teams. This is an example from last year's teams. This year they're still just, I'm missing this week their current presentations. Finding water, this is in Kibera, which is one of the large, what they call informal settlements, otherwise known as slums, around Nairobi. And people don't have running water. They have to get water, carry it in these cans to their house. And when there's water shortages, they may have to go for hours finding where there's available water. Cell phone penetration is very high. And any of you who've looked into the third world know that amazing sort of leapfrog in cell phone. So this simple application called embodied is a way to use the cell phone to help find, both for the buyers and the sellers, where water is available when there's these shortages. So that's an example. And I said in my abstract, and we're getting toward the end of the hour, that I would project a little into the future. I would talk about sort of where Kai is going and what kind of research we might do. So if we look at a question of what kind of research should be done, first of all, I'm afraid my answer is a bit what you would expect, which is all of the above. So, computer, there are all sorts of wonderful new computer technologies being developed. You know, fold-up computers and new kinds of chips and new kinds of sensors and new kinds of interactions and so on. That's always a source of inspiration. When I go back to things like Park in the 70s, that was a source of inspiration, was the new technologies that could be developed. So that's always going to be an important strand. The human, and I use here sciences in a broad way, I know, because I don't want to get into my science fair days of what is it really science, but it's deep sort of analytic studies of people and what they do and how they do it. And this has always been another really important strand of Kai research, which is in psychology or sociology or anthropology. It's the part which is understanding the people that we're designing for. Interaction, there is a world of interaction mechanisms. I hope you all get a chance to go up and see Bill Buxton's display up on the second floor, or I guess we're on the second floor, of devices from the past few decades. And there are always new ones, multi-touch, connect. I mean, as we go on, we're discovering new ways that people can interact. So, none of those is ended. They shift. And what's interesting is they shift over time. So the human sciences that are relevant today to Kai aren't the same ones that were relevant 20 years ago. And that's not just a matter of being trendy. It's a matter of opportunity. It's a matter of what are the new possibilities and what's the new understanding of people we need. Social understanding becomes important when people are using social device, computers as a social device. They weren't so important when they were sitting there typing word processing letters. Right? It was a different question. So over the years, we've seen a shift through these various disciplines. None of them go away because they're always relevant, but certain ones are the place where there's the most to dig out. And I think any of you who followed Kai over the years certainly know that. I didn't have a clever word to put there for design. I started with methods, but that was too narrow. Design thinking, but that's too broad. It's not exactly clear how to crystallize it, but this way of design thinking, this way of approaching problems as a human-centered, need-finding, trial by error. There's a whole set of processes we worked out in the D School. I think there's a lot to be done, which is research as well as practice. And I think one of the things that for me has been the big lesson there is the degree to which it's grounded in specific settings and needs. Earlier I mentioned that I didn't think that the iRoom really succeeded well in integrating. I could tell you about half a dozen other projects I've done over the years that you've never heard of, rightfully. There was something called Aleph, a general specification language, a hub, which was a network of information before the web, Infobase, which was a kind of Wikipedia-like thing, but not done with crowdsourcing. And so in each of these, I sort of had this very big general view of why it would be good to pull everything together and wasn't letting it emerge from what are people actually doing. In my work in the digital libraries, one of my colleagues at Stanford was Hector Garcia Molina, and he once said, not to me, but to somebody else, you know, some people think top down, and some people sort of think bottom up, and I think Terry thinks top up. So, my lesson on that is sometimes you need to really start grounded. You know, the bottom is important. You can't start with the top and move up and do the abstractions. So the real question, I would argue, is not what research should be done, but put it in your own terms for each of you and for me. How do I design my research? And I'm using design here, of course, intentionally. The lessons I've mentioned, one is be ontological. And again, I apologize for the trendy philosophy word, but what it means is think about the underlying meanings and shifts in how you view what you're doing and people are doing, not just the details of how you get it done. Shifting from operations to the commitments people make and deal with in their work was an ontological shift. Shifting from information to meaning, to why you're communicating, who you're communicating to, is an ontological shift. Those are big things, but often you get a chance to see a new opportunity because you make that kind of approach. Challenge your own assumptions, okay? And I think I've pointed out several places in switching from AI to more of an HCI approach and switching from organized data structure to more of the Google approach, places where you step back and say, what have I been assuming in the large about where things are going that I might question? And if I question that, where do I go that's different? And that's often very hard to do, but it can be the places where the real breakthroughs happen. And sometimes it's a gradual drift. I did not, at some point, say, I'm no longer in AI. I don't believe in it. It was a course of years of, as I mentioned, those discussions with the Berkeley philosophers and so on. And at the end of it, I said, what have I been doing? And that's the point where you can sort of switch. Be open to opportunities. This is, again, sort of motherhood and apple pie. Everybody always believes it. But it's harder to do than to say because you're always so engaged and so involved in what you're doing. And often opportunities are things like the coming together of timing. I mean, Park was so successful in its early days, 70s, early 80s, because there were a whole bunch of technological strands which had reached maturity and could be brought together to do something. 10 years earlier, they couldn't have built it. 10 years later, it would have been too late. And I would say the same thing with the web and Google. Right? Google wasn't something that nobody could have imagined before. It's just at that point, enough had come together on the web, enough had come together with machine processing that you could do things in core and so on to make something possible. So often it's not what you do, but where the world is going. And of course, you want to try to be able to get onto that, to read it, to see it. There's also opportunities with people. As you may have noticed, most of the things I point out here grew out of collaborations. Okay, I did work with Fernando Flores. I did the D School with David Kelly. And for me, and of course, along with those collaborations, the collaborations with the many, many wonderful students that I've had over the years, often that will help you see something you didn't see. Right? So I'm a strong believer in collaborative research. Again, with Josh Cohen on the Nairobi course. And finally, and again, this is a very broad question, but what I call seek meaning. I mentioned that Larry Page credits me with giving him the most useful advice. What we really did when they were doing the work is run interference. So they had the idea, they were going to do it, and we got these calls from the computer networking people at Stanford saying, what the hell are they doing with all this network bandwidth? Or from this guy in Singapore who said, we're going to sue because you're downloading all my pictures, and so on. Right? So we can serve, as faculty, a very useful role in helping facilitate what students do. And the advice I gave him, he mentioned, was basically do what you think is important. He came in with a bunch of projects, and I could tell, just listening, I didn't have to think about what the projects were. You could see the energy. You could see this is what he really cared about. And the fact that it wasn't a particularly good dissertation project, I said, well, I'm not sure how you can make a dissertation out of that, but give it a try. And as you may know, he never did make a dissertation out of that. Follow what's important. Follow what you think is going to matter to you and what's going to matter to the people you're dealing with, the people in the world at large. So the answer to where the field is going, which I hinted at that I would give earlier, really is an answer. It's a question. The question is, what are the meanings that matter to you as an individual and as part of the larger CHI community? So I look forward to hearing many different answers to those questions over the coming years, seeing a lot of exciting research growing out of them, and I thank you again for the honor of receiving the award.
We've run over a little bit, but now is an hour-long break, so if you'd like to stay and answer a few questions, there's a microphone, but you're certainly welcome to go and get first dibs on the break food.
If you're willing. Thank you, Terry. It's Ben Schneiderman, University of Maryland. Thank you for a wonderful talk, a review of history, and a characterization and a sort of and a direction for this community. We in this room are really, I think, proud to be your colleagues and happy to be your disciples. And what I want to ask you in that way of your leadership and top-up thinking is you've characterized a wonderful progression, which I share with you, of how the CHI community has grown, progressed, and also taken on visionary, ambitious, and important goals. But we are still only 5,000 of the 108,000 in the ACM community, and I know you and I have talked also about when we appear in other general computer science communities, we're still an outlier community. And the question I want to ask you, or I hope engage people here, is how can we help spread this idea, these ideas, and the suggestion that the goal of our research, our technology, our academic work is to seek meaning, is to bring benefits, and to be, construct a positive world. I think those are implicit, some you've made explicit, but how can we help make more of the visions and concepts you've presented to us today?
A very good question. I mean, I have to admit my first reaction comes from the job I've held for all of these years, which is teaching, students. I mean, one of the things that we're doing, I mentioned the D School doesn't have its own students, so the students who are taking the courses come from every department, every school and university, from earth sciences, law, philosophy, whatever, as well as engineering. And I think when they go through this process and do design and then go out into whatever fields they're going into, I think that has the influence of creating a broader understanding. Now, it's different from direct public information, but I think certainly the way that I've been trying to do it.
Mm-hmm. Okay, I mean, maybe we'll continue it, but I just encourage you to talk about not just as a reflection in the past, but a call to action in the present. You've done that in the past as, CPSR and other ways, but I think people in this room want to make more of this, and if you can find the ways, we will follow. Thank you.
Thank you.
Hi, I'm Richard Davis from Singapore Management University. First thing I want to do is to thank you, because it's because of you that I'm here today, because I was a new student working at Intel, and I was so bored with my life. I snuck into your HCI seminar, and I loved it so much, I found a new life. So thank you. My question is a little less sweeping than Ben's, but I'll ask it anyway. So you've taken a great interest in design, and I'm very curious to know your opinion on something. In recent years, it started to look like in this community, the word design is sort of synonymous with innovation. I noticed in your picture there of Dave Kelly, it said innovate relentlessly. That was next to, the idea of design. Do you think design is the same as innovation, or is innovation necessarily tied to design, or are these two slightly different things that have gotten tied together somehow? I'm curious.
It's a good question. I mean, I think design has, as with all words, gets trendy, and lots of people just want to throw it in what they're doing. Innovation's also that. I mean, in some sense, I would say design, for me, is an orientation, an approach to how you go about things, and innovation is a result, right? So the claim is if you do design thinking, as we call it, you are more likely to be innovative. I think there are people who innovate from other directions. I mean, there are people who just come up with an amazing invention, not human-centered, not doing all these steps, but just, the light bulb goes on. So I think there are other ways of innovating, but they're certainly linked.
Thanks.
Ted Selker. I've always enjoyed listening and talking with you, and your quick way of responding and thinking. And I guess this, there's this caricature of an art historian as somebody that couldn't do art, and an artist is somebody that couldn't analyze what they do. And I guess I just know that in different times of your life, you're a big listener, and yet you're a creator. And I just wonder what you think about that whole balance, and how do you cross that chasm of evaluation and design? And I think this community, of course, has struggled with that. And anyway, just that's what
It's a good question. I mean, we have these sort of mottos that we have for the D School, and one of them is be reflective. So you can't be reflective if you aren't doing something to reflect about, but also reflect on it. I think it's that combination of action and then reflection on the action, as opposed to one to the exclusion of the other.
Terry, I just want to add to the thank yous. You have been an amazing leader, and you've been so very generous to many of us over the years, and I know you will continue to be like that. And just thank you for being who you are. Thank you very much.
That's very kind. Thank you.
Hi, I'm Scott Mainwaring, as you know, from Intel.
Former Stanford student.
Labs, and I will join the parade of people thanking you for a large part of why I'm here today and interested in the things that I am. I wanted to go back to your slide that I thought was really evocative of all the different metaphors for what a human is. Mm-hmm. And one that I've been, I guess, struggling with, maybe in a productive way, is this idea that a human is a consumer. And I think this also ties into Google and Facebook and a lot of these platforms which are about entertainment and advertising and more than information seeking and that side of things. And I just wondered if you had...
Yeah, you touch on two different ones. Actually, I had a longer list at one point and got advice from various people, including Scott Clemmer, who is over here, my colleague at Stanford, who's been a wonderful colleague the last few years, saying, cut it down to the ones you actually have some connection to. Otherwise, this is going to be this long laundry list. So I think viewing people as consumers is predominant in a lot of this society and has its good and its bad sides. I mean, I also had one viewing people as, and the word I had was players, but that's probably the wrong word, but what is it you're getting to when you build games for people? What is it that makes them want to play, which is different from being social or doing work or all these other things we mentioned, and is an important part of human activity. Your point is well taken. There are other views, and I could put a list of, I'm sure somebody else who could put a list of 3 or 4 or 5 more, which are really influential, and that's one of them.
Right. And it just dawned on me that your water buying and selling application in Kibera is certainly getting into the realm of consumption. And
Liz Gerber, Northwestern. I've had the privilege of teaching with you, Terry, and I'm wondering if you can reflect on, your last point was one of meaning making, and also your interest in design, and I'm wondering if you can reflect on the idea that the process of design is actually inherently meaningful to people. So it's not just creating products that are meaningful for other people, but the actual enactment of the design process as one of personally meaningful to people, and the way in which you see students embracing that as a different way of being in the process, not necessarily focus on the outcome.
Yeah, no, I think if I'm getting what you say, I mean, one obvious example, so this course that I mentioned about in Kenya is the only course that I've taught where we have 24 places because it's limited the way we can deal with teams and so on. We had over 90 applications for it from really highly qualified students. And I think the sense that you're doing something important and having meaning in the process yourself really drives students. I think we can be cynical about students today and what they care about and so on, but really when you see what they believe in and what makes them really want to do something, I think that sense of meaning in the process of design is a very important part of it.
Thank you.
Terry, I wanted to ask you a question about interdisciplinary work, because I think as wonderful as the picture of HCI being a conglomerate of disciplines, I think for all of us is very clear that doing that kind of work in some kind of depth is very, very difficult, because there are even lines of thoughts within each one of the disciplines that contradict each other and see things in a very different way. So I wonder if you have any words as to how to capitalize on those contradictions and doing it to a level that would really do injustice to the different disciplines that are represented there.
Yeah, that's a good question. I think there's 2 slightly different flavors of that. One, which is more fine-grained, is you will find places where 2 disciplines, or often 2 people who come from different disciplines, discover they have something really interesting to say to each other. They're from communications and engineering, whatever it is. And I think those cases are just sort of natural outgrowths of being open to these connections. But what we've said, and again, this is part of our core principles for the D School, is you don't be interdisciplinary by doing a little of this, a little of this, a little of this, a little of this, a little of this. What you do is you tackle a problem and you use all the disciplines that are needed to make the solution work. So when you go in, let me pick that water example, being able to design things on cell phones is only a very small part. Understanding the politics is huge. Understanding what would make people motivated to use it or not use it is huge. So you just naturally draw in multiple disciplines due to the specificity of the project. And I think that's a very different starting point from traditional sort of research interdisciplinarity. Okay, thank you all.